Good day. So in this lecture, we'll discuss about cleaning and processing the data. So why do we need to clean the data first? So this is an important step to remove the null or problematic data. So for example, if you have um, parts of the data that are empty, for example, if you visualize it in Excel, you have empty cells or cells that have NaN in there, or even data that has negatives where it shouldn't have negative values. So those are your problematic data. You can also reduce dimensionalities. Uh, Basically, when we say reduce dimensionality, because for big data, there are a lot of columns and rows. Basically, you have a lot of parameters, and those parameters or features are usually interconnected. So sometimes it's very difficult to actually make sense of the information of your data without first reducing the dimension, or basically you want to simplify the data. Of course, during reduction of dimensionality, there are some uh, information that might be lost. But then again, we if you want to make sense of your data, it's actually a necessary risk. And of course, to transform categorical data, because in data science, we are reliant on computers, and of course, at its heart, computers are deals with numbers. So if you have categorical data or even unstructured data such as images, you need to transform it into something that can be analyzed, calculated, and processed by your machine. So basically, data cleaning is a very important step prior to machine learning. So if you want to read feed the information or your data in a machine learning algorithm, you need first to clean your data. So let's see what are those. So how do we actually clean by first removing and detecting null data? Actually, in our example, we will only be dealing with detecting and removing null data, null values in data frames. Because if you remember, the data that we have, because we will be building up from what we have previously, which are the COVID cases in the Philippines. So we have structured data there. And the dimensions are very small, so we don't need to do we don't need to reduce the dimensions or transform any categorical data. So anyway, this is just a simple detection and removing data. So this step is almost always used. Dimensionality reduction and transformation are only used when necessary. For example, when we're dealing with um, gene expressions. Gene expression analysis, it contains thousands of genes and thousands of information. So you have a lot of data to analyze. So anyway, so let's move on to the spider console. Okay, so here in our spider console, so I have here a code for cleaning data. But instead of running this whole code as one, let's look at each line one by one. Now, this is, I'm going to use the data the CSV data that we saved from the last activity in BigQuery. So if you remember, at the end, you save it as a CSV file. So in order to do that, we need to make sure that we are running the Python console in the same directory as our as the CSV data. Otherwise, you won't be able to access it. So I have here my let's say coding cheat sheet. I have here importing pandas and numpy as the two libraries that we'll be using, and we will going to call the CSV file. So I'm going to run this first as a Python file, where this Python file is actually saved in the same directory as the as our CSV file. So that's why I'm going to run it, not not going to use the console immediately, but I'm going to first run it here as the as a Python file .py, where this .py or this Python file is in the same directory as my CSV file, so that I won't have any trouble defining the file path of my CSV file. So let's run it. Okay, so no error messages, so we are now on line 2. Now, I'm going to remove this triple quotations. So if you remember, triple quotations denote that the text, the codes inside the triple quotations are text files and should be ignored by the Python, ignored by the Python. Okay, so this is my data. So I want to see first the headers of the first few rows. So I'm going to just type it. So print from the data. So we have df. This is the data frame because we entered the CSV file into the df, which is the data frame. So df, I want to see the headers. So this is the headers of our data. So we have country code, country name, population, etc. So we want to know if we have columns with similar values. So print again. Print is basically it gives us the output of what we are looking for. So we want to find columns with similar values. So df.n unique equal 1. So that means equal. Remember, this is a comparison, or basically greater than, less than, equal. So basically a comparison. Okay, so we have this data country code. Actually here the country code is not really the country code but the dates. So false, that means these contain unique values, so we have different values. Country name, so since we are only looking at the data from the Philippines, so it's true because the whole column contains only one value, and that's Philippines. Cumulative confirmed, cumulative deceased, cumulative recorded, of course they are false because the number of confirmed, deceased, and recovered cases every day is changing. So they contain unique values. Now, population 2018 has same values all throughout. So basically it's true because this is from the 2018 census. Or rather, the world data from the census updated last 2018, because the Philippines took census, the last time we took census is 2016, but then again probably finished at around the end of 2017. So basically this is from the actual 2016 census. Then case percent, you have non-unique data. So we have here two columns that has the same value. So to reduce the columns that we have, so we can drop those columns. So to drop these columns, so I'm just going to copy this code. So this is the code to drop the column. So I'm just gonna copy it to the console. So I'm not going to run this whole Python file because we want to see each the result of each code or each line every step of the way. So df drop columns where you have a non-unique value. So we're going to drop those values that are returned as true. Okay, so there you have. Now let's see those columns again. Print df.head. So let's look at those columns. So as you can see, there's no longer country name and population 2018. So you have country code, cumulative confirmed, cumulative recovered. Now here we have, of course, the names of the headers are too long. We want to change them. And especially this one, this is not actually the country code, but rather the date. So let's rename the column. So we have two ways to do that. So the first one is to df.rename columns. But when we save them, it doesn't really stick. So the renaming doesn't really stick. So rather than df.rename using this command df.rename, so we can just say df.columns and then rename each and every column in the order they appear in. So I'm just gonna copy paste this one because I tend to do typo errors. Anyway, so df.column. So this is a much, in my opinion, much better way to rename the columns rather than using df.rename, because again, the rename doesn't really stick when you rename the column. So the names of the columns, so we have country code, cumulative confirmed, cumulative deceased, the cumulative recovered, and the case percent. So I want to change those names. So you have the date, confirmed, deceased, recovered, and percent cases. Now, if you want to see the full data that you have, you can open it, the actual CSV file, you can open it in Excel or even in Notepad. So let's, so that you can see, because here, Spider, unfortunately, truncates data if they are too long. So let's look at the cases first. So let me call on the data so that you can see the actual names that I have been using. So this is in data science. So the name is COVID cases. Okay. So let's switch the view. So we have the CSV file. Okay. So this is the CSV file. So as you can see, because this is open in a notepad, so it's not really arranged that well. So as you can see, country code, country name, cumulative confirmed, cumulative deceased, cumulative recovered, population, 2018, and then case percent. That's the original one. So we dropped the we have dropped our we drop the name of the country and the population. So we are left with cumulative confirmed, cumulative deceased, cumulative recovered, and case percent. So we are going to rename them. So we have now renamed. So again, let's see what let's print the headers again. So as you can see, we can now visualize the full column. So date, confirmed, deceased, recovered, percent cases. So you basically that's how you rename the column. But if you want to rename specific columns only, you can do the df.rename. But again, as I said, they don't really stick. Okay, now let's see. We have here values that are empty, such as NaN. So that means you have empty values. So we want to see if you have null or if you have columns that have empty values. So we just write the whole df, print. So we want to print, so we want to see if the null values, df that is null. So this is an empty parenthesis because we want to see all of the null cases here. So basically, it returns to us the same the same table, but you will see here, you have, when we say true, so basically those are null values. So NaN, those are null values. So if you remember, it starts from January 1, 2020, and we still haven't had a recorded case of COVID by then. So it's around, I think it's the end of January where we had the first case. Well, I remember it was March when we implemented the lockdowns. So I think those were several days after. Anyway, so this empty value, so sometimes we have empty data in our script. So first, we need to fill those empty strings with basically a value such as NaN. So this is basically a code. So when we say empty, if you have just empty spaces, so you want, sometimes kasi the empty spaces is either blank spaces or it has NaN or even Na. So for us to easily replace those NaN values with a different value, so first we need to homogenize, or basically make them uniform, those empty values. So this code, so we are going to replace this. This one denotes empty spaces. We are going to fill them with NaN. And then we are going to fill all the NaN with 0. df dot fill Na with 0. Okay, so as you can see here from the difference, so this is the original file. So we have 0101 NaN. So this is, it changed to 0. Okay, so the 0 values change. So only the null data are changed to 0. So sometimes it's 0, sometimes it's the mean of the immediate rows that we have. So depending on the data that you have. So in this case, we are using COVID data. So you don't want to use means. If it's a blank, that means there's either no information or 0. So we're just going to change it to 0 rather than manufacture new information on the statistics of COVID cases. Okay, so we have several days. For example, the beginning of January, we don't have any cases. And since these are just dead weights, so you want to remove those dead weights. So we can drop those rows that have values of zeros, all of them. So we drop this axis. So we have basically this code. So df dot drop Na. So axis is equal to 0. So it will remove the 0 cases. So as you can see, if we started in the date of January 1, so it removed all of the dates that we have no cases. So here we have started in January 23, the first recorded cases, and then that case died around February. So if you remember, it came from, the first recorded case here was from a Chinese woman from Hong Kong, and then her and her companion the day after was diagnosed as a positive COVID case. And then several days after that, if you remember, the companion died, or is it, yeah, I think it's the companion who died, and then the woman recovered. So that is well, the story of how COVID how COVID apparently entered the country and spread from there. So it started with one case and then ballooned out into this case. So the last data is until January 14. Okay, so we have now cleaned this data. So for further analysis, we can either do other analysis, find the means, or even especially from the last times last week's activity is to show the data as a date progression or time progression. So, or alternatively, we can save it to a CSV file. So we can save it as a CSV. So I'm just going to copy paste because it's long. So I want to save it, this file to let's say the clean data. So PH20 COVID clean CSV. So saving this one. Okay, so we can view the data now. Let's see the data. So I'm going to change views. So here is your COVID cases. So this is in CSV file. So basically we have our data cleaned. Okay, so you can there are no longer NA files and you have zeros in its place. So basically that is your cleaning. Basically this is most of the basics, just the basic cleaning out of your data. So going back to the presentation. Okay, so going back. So that is cleaning and removing null data. So in the next video, let's do a simple review of statistical tools that we have.